IGCSE Computer Science, Syllabus Statement 1.3.6a. Describe the I'm used to saying the principles of operation. It's stuck to my head now. So this video is about operating systems, and the good thing is this is the only video on operating systems. The next video is 1.3.6, but it talks about interrupts and buffers. So what is an operating system? Well, an operating system is software which runs in the background of a computer system and manages the basic functions. So what operating systems allow you to do is, it makes it possible to communicate with software and hardware of a computer system. So without operating systems, computers would be user unfriendly and people would find them hard to use. Now this doesn't really make sense at first, but once you see the functions, you'll sort of get what operating systems do, and we'll also look at what happens when you turn a computer on, what the operating system does. So here are some of the basic functions. So managing the human-computer interface, allowing us to, communicate with the computer. Multitasking. So you notice this in all modern day computers, I think. You can multitask. So you could use two apps at the same time. It's quite cool. Multi-programming, batch processing, error handling, loading and running software, managing user accounts. So if you have a family computer that's in your living room, for example, or a computer room, then you may have your account, your parents' accounts, your grandma's account, and so on. Controlling input and output, managing security, interrupt handling routines, real-time processing, managing memory, managing the processor, and performing file functions. So if you're copying a file and pasting it, if you're deleting it, you get the point. So you may recognize most of these functions. You may recognize them as what your computer can do. So that's pretty much what an operating system does. Now, of course, an operating system won't necessarily perform all of these functions, but these are just examples of what they may perform. So when a computer is turned on, the startup programs located in ROM are loaded into memory. And these programs check to be sure that things such as the hardware, processor, internal memory, and BIOS are functioning correctly. If no errors are found, the operating system is loaded into memory. So that's pretty much what happens in a nutshell. Yeah, that's pretty much it. But it's important to know that some devices with microprocessors don't require an operating system. And this is because if they have only one function, then you don't need those other functions. So you don't really need to manage a whole bunch of functions if you have one function. So a microwave, for example, just to heat up food. So that's pretty much it. IGCSE Computer Science, Syllabus Statement 1.3.6b, show understanding of the need for interrupts and buffers. So what we're going to do is look at interrupts and buffers, but now this is because we have looked at interrupts and buffers really briefly when we looked at printers, but it's important that we know what actually is going on. So what an interrupt is, what a buffer is. So that's what we'll do. And then after that, we'll look at how interrupts and buffers are used in printers. It's going to be more specific than what we looked at in the printers video. So yeah, let's just get started. So an interrupt is a signal sent from a device or software to the processor. And this signal stops the job which the processor is currently carrying out temporarily to service the interrupt. So it's kind of like if someone's, you can think of it like this. So if someone's working on something, if someone's, say, typing something or doing their work, and then some somebody comes up and says, "Oh, hey, could you please, I don't know, could you please carry this box for me?" Or like some kind of task, then what the person can do is interrupt, well, not interrupt, but yeah, so that person is interrupting that person. So the person who's working can stop what it's doing, what he or she is doing, what they are doing temporarily, and then help the guy carry the box, and then come back to working. So that's pretty much how it works, kinda. So when the interrupt is received, the processor either continues doing what it's doing, so the person working just ignores the person and says, nah, nah. Or it can stop the current task to service the device or program, or in the example, the person which sent the interrupt. Interrupts allow computers to perform multiple tasks, or to have several windows open at the same time. So whenever an interrupt is serviced, the status of the currently running task is saved, and this is done by using an interrupt handler. And once the interrupt has been serviced, the status of the interrupted task is restored, and the processor continues what it is doing, or the task continues, or you get the point. Buffers are a little bit different. So buffers are used in computers as temporary memory. The purpose of buffers is to speed things up. And this is because hardware is very slow compared to a processor. So you can think of it kind of like this. So a processor is sending, let's take a printer, for example. Printer is an example of hardware. So say the processor of a computer sending data to the printer. Now, here's the thing. What the processor needs to do is keep sending printer data until it's finished printing. Now, what this does is the task of sending this data to the printer is the currently running task of the processor. So the processor can't do anything else while this is happening. So this is where buffers come in. So instead of the computer sending data to the printer, it just puts it in this buffer, and the printer can collect that data from the buffer, and the processor can continue whatever it has to do. So it's pretty much like the computer puts this data in the buffer and says, "Oh, hey printer, I'm just going to leave this data here in this little box here, this buffer, so you can pick it up from there. I can continue whatever I'm doing." The printer says, "Oh, okay." So that's pretty much how it works. Data from a processor or memory unit to be sent to a hardware device is stored in the buffer. And the hardware device can get this data as pretty much what I just said. So let's see how interrupts and buffers work with printers. Now, this is a bit weird because the title is kind of, it's a bit weird, but you're going to see why I put it there. The flowchart that I used here is really weird. So any data to send to printer? Nope. Then the processor continues to carry out its tasks. Yes. Then the print data is sent to the buffer from computer memory. The contents of the buffer are emptied to the printer, and the printing takes place. All data sent to printer? Nope. The processor can carry out other tasks while the buffer is being emptied, so the processor doesn't have to keep sending the printer data. Yes? Well, when all the data has been printed, an interrupt signal is sent to the processor to request more data to be printed. The current task is stopped temporarily, and the interrupt is serviced, so the processor puts more data into the buffer for the printer to collect. So that's pretty much how it works.